So, welcome to Study Physics. In today's lecture, we will be solving the problems of chapter 12, that is simple harmonic motion, and today's first problem will be 49th. So, in the 49th question, what is asked is, a uniform rod of length L is suspended by an end and is made to undergo small oscillation. So find the length of simple pendulum having the time period equal to that of rod. So in this problem we have been given a rod of length L. So just consider that this is one rod and the length of the rod given is L. So it's looks like not a straight rod, but you have to consider it like that. It's my drawing problem, so hope you will consider. So this is the point of suspension of the rod according to the given problem, and if we consider that this is the point of center, so from the center to the point of suspension we can consider the distance equals to L by 2. So this is the case for first part, and we have been asked to compare the time period with a simple pendulum. So for a simple pendulum, what we know is we have a thread and a mass attached with it is suspended through some fixed point. So this is our simple pendulum case for the simple pendulum. So if we think that the time period for this pendulum is suppose T2 and the time period for this is suppose T1, so we have given that T1 is equals to T2. By that time we have to evaluate the length of this simple pendulum. So just consider the length of simple pendulum as L dash here, because we have considered, or in the problem the length of uniform rod is L, so we just consider the length of simple pendulum as L dash. So now let us evaluate the value of time period for T1. So that will be like 2 pi under root I by mg and distance between the center to the point of suspension. So it will be L by 2, so we can write it like 2I by mgl. Okay, so now we have to evaluate the value of moment of inertia. So just first consider the moment of inertia about the central point. So for a uniform rod, the moment of inertia about the central point is just ml square by 2l. So we know that about the central point the moment of inertia will be ml square by 2l. But for this particular problem the moment of inertia required is about the point of suspension. So here the point of suspension is this point. By that time the moment of inertia about that point will be moment of inertia at the center of mass plus moment of inertia because of the suspension point. So that will be like we have to consider the entire mass here and distance between the center to the point of suspension multiply to it. So just for first case, if we say that the mass is m and the distance between central point to the point of suspension is x, by that time we have to write it like that for moment of inertia due to this part. So by that time we can write ml square by 2l plus here the value of x will be L by 2. So x square will be L by 4. So this value will be 2l and this value is 2l. By that time it is ml square plus of 3 ml square. So moment of inertia is like 4 ml square by 2l. So it is ml square by 3. So moment of inertia about the suspension point is ml square by 3. So now we can easily calculate the value of time period here. So from the first part, the value of time period will be 2 pi under root, we have written it like 2i divided by mgl. So we can write 2i divided by mg and l value only. So it is 2 pi under root 2 into I value is ml square by 3. So it is like 3 mg and l value. So L and L cancel, M and M cancel. So by that time it will be 2 pi under root. So here 2 and 1 L term is there, and in the denominator part it is 3g. So we can say that the time period for first case is 2 pi under root 2L by 3g. So we have evaluated the value for first part, or we have evaluated the value for uniform rod, the time period for uniform rod. And time period for a simple pendulum, we know that 2 pi under root L by G. But for this particular problem, our L is like L dash. So we have considered like L dash na. By that time we have to write the time period for simple pendulum as L dash upon G. So L dash upon G. So first is this and second is this. So according to the given problem or question, the T1 is equals to T2. So we can write 2 pi under root 2L upon 3G must be equals to 2 pi under root L dash upon G. So 2 pi and 2 pi value will be cancelled. By that time we will be getting 2L upon 3G is equals to L dash by G. So from here L dash value will be 2 by 3L. So in terms of meter we can write, so 2L by 3 meter we can say. So if a question is given in terms of meter, then we can write meter, otherwise not required. So we can write it like 2L upon 3 also. So in the meter it is not mentioned, so we can write like 2L by 3m. So in the problem it is not mentioned that L meter, so we can write it like this. So in this way we finished the problem 49.